Chemistry, Unit Intro. What should you recall about physical and chemical properties? Properties of matter can either be physical or chemical. Physical properties are properties you can observe or measure for a particular substance. Physical properties you can see and describe using words such as soft and red, and are called qualitative physical properties. They describe the qualities of the substance. Physical properties that are measured, such as temperature, are called quantitative physical properties. They describe quantities or numbers associated with the substance. Physical properties describe how substances can change when they interact with other substances to form new substances with new properties. Chemical properties can only be observed when substances interact in a chemical change. That's an important point to note, that chemical properties can only be observed when substances interact in a chemical change. I'll have you watch this video, then come back to this slideshow video. Here is a table of physical properties and their descriptions. So we have qualitative, okay? So state would be talking about whether something is solid, liquid, or gas. Something's color, okay, whether it is malleable, that's its malleability, that's its ability to be bent or beaten into sheets. Ductility is its ability to be drawn into a wire. Texture, its appearance and the feel of the surface, is it rough or smooth, things like that. Magnetism, of course, its tendency to be attracted to a magnet. And then luster, okay, the degree to which the material reflects light, how shiny it is. Now, quantitative, solubility is the first one. This is the ability of something to dissolve in water, right? Like you dissolve sugar in water, you can dissolve salt in water. It's a physical change. There's nothing chemical happening there. Conductivity is the next one, is the ability to conduct electricity or heat. Viscosity, resistance to flow. Okay, so if any of you are in automech or know there's different viscosities for oils in combustion engines, right? We have a more dense consistency for winter for oils that resay that. Viscosity, this is a resistance to flow. If any of you are in automech, you'll know that that different oils have different viscosities. That's the resistance to flow through the engine. Okay, density, this is the ratio of material's mass to its volume. Melting point, temperature of melting or freezing. Boiling point, temperature of boiling or condensing. Now on to chemical properties. We have reactivity. This is the degree to which a substance combines chemically with other substances. Okay, water, oxygen, acid, and other substances, how they chemically combined. Combustibility, the ability of a substance to catch fire and burn in air. Stability, how easily the substance breaks down to form other compounds. Toxicity, the degree to which the substance reacts in the body to produce harmful substances. Remember back to the ecosystems unit when we talked about bioaccumulation. That was referring to toxicity, right? The degree to which the substance reacts in the body to produce harmful substances. So substances, now on to physical and chemical changes. Substances can go through physical changes and chemical changes. Physical changes are generally changes of state and can usually be reversed or undone. A cup of water can be frozen into ice. It looks different, but it's still water, just in solid form. It is possible to reverse this change simply by melting the ice back into water. So again, this is an example of a physical change. Chemical changes produce new substances with new properties and are difficult or impossible to reverse. The example I give you here, you can mix together all the ingredients to make a chocolate cake, add heat, okay, that's the oven, and then it makes a new substance, the cake. Right? It was batter, this gooey batter before, and then it became this fluffy, spongy stuff, right? With lots of air bubbles in it. This change cannot be reversed or undone. Some examples of evidence that a chemical change has taken place include the following. The formation of bubbles, okay, of gas. Okay, when baking powder and vinegar react, we're talking about different kinds of examples here. The change in color of a pair of blue jeans that have been exposed to bleach. If your mom has ever accidentally gotten some bleach on your blue jeans, right, and that was a style in the 80s, acid wash jeans. The formation of a precipitate, such as the formation of soap scum, when soap and minerals in water react. A precipitate, just as the word suggests, so to precipitate is, you've heard of precipitation, water falling down, right? So it is a substance that comes down in a solution, and so of course the example I give here is of the soap scum that comes from combining soap with some minerals. The light and heat produced from a campfire, and the sound of fireworks. So again, we have gases produced. Okay, we have color change, a precipitate, light and heat, or sound. It's usually safe to conclude that a chemical change has happened if you have observed at least 3 of those things. So remember that everything is made of matter. Matter can be classified according to the categories shown in the chart below. So if we have matter, it can be broken down into mixtures, okay, and pure substances. Mixtures, we have mechanical mixtures and we have solutions. Pure substances, we have elements and we have compounds. According to the particle theory of matter, pure substances contain only one type of particle. They cannot be separated into other substances by physical means. Pure substances are either elements or compounds. Elements cannot be broken down further by physical or chemical means. Hydrogen is an element. It cannot be broken down further. You can't break hydrogen down into something else. It's always just hydrogen. Compounds are composed of more than one type of element and can be broken down into elements by chemical means. Water, for example, is H2O. Okay, water is a compound that can be broken down into 2 hydrogens and 1 oxygen. You can see the chemical formula here shows us that. We have 2 hydrogens and 1 oxygen. When there is nothing written beside it, we assume that there is a 1 there. We do not assume there is a 0. If there was a 0, there would be no oxygen here. And so we have H2O1, okay, or H2O. According to the particle theory of matter, mixtures contain more than one type of particle. They can be separated into pure substances by physical means. Mixtures contain more than one type of element or compound. They can be homogeneous solutions, which are uniform throughout, or heterogeneous, which are mechanical mixtures, okay, which have varying compositions throughout. So salt water is an example of a homogeneous mixture. It is a mixture of water and salt, but you can't tell by just looking at it that it's a mixture. You can separate the salt into water and salt. Right? If you just simply boil it, you'd be left, and as the water evaporates, you'll be left with salt. Okay. Trail mix is an example of a mechanical mixture or a heterogeneous mixture. Okay. You can see all the different parts. You can see the peanuts, the raisins, the M&Ms or Smarties, whatever those are, the cashews. Okay, you can easily separate out the parts.